This call is now being recorded.
Okay, sorry. Okay, I'll repeat in 5 minutes. I think I need to thank Tushar. Okay, thank you, Tushar. I have not seen that. Okay, so in the state space analysis, right? So this is for your in the normal conditions of analysis of the system. You are having one single input and single output. This was your control system, and your input was and output were both were single, right? So now in this and there was no initial condition, right? So your fan was running from 0 speed till the 5 speed, right? So we are incrementing sequentially every 2 seconds, right? And after that there is no initial the assumption was that in a regular system that initial condition is 0. Now, so in the state space analysis, suppose if I give multiple inputs and the initial condition is there is some initial condition existence, then output also will be multiple outputs, right? And here initial condition is not 0. It means suppose there is fan which is running from 0, 1, 2, 3, 4, 5 speeds, right? So if I start my analysis from see, if each is incrementing by 100 rpm, each speed is incremented by 100 rpm. Suppose if I start analysis from 300 rpm, right? So these analysis will come under your initial conditions, right? And after this will come under your regular assumptions, right? Okay. Now in your state space analysis, you are doing assumption for not assumption. You are taking into account both the initial conditions plus multiple inputs and multiple outputs. So in the analysis of system, your initial conditions are 0 plus all the initial conditions are assumed 0, and you are having single input as RS and single output as CS in your regular systems, right? So if there are multiple inputs and multiple outputs are given with initial condition not equal to 0, then state space analysis will be done. So the basic block diagram, so you are solving this multiple input, multiple outputs. You are solving the block diagram, transfer functions, and the stability. Plus, you are learning the state transition matrix, the zero input response. Zero input response means the input is 0. It means your U of t. In the previous case, this U of t is 0. If this is 0, still you'll get some output. See, suppose if you run a fan, right? Suppose you are doing every 2 seconds, you're increasing the speed, right? So after, so this is your 2 second, and here is your 2 second, and here is your 2 second, right? So after 6 seconds, you want to do analysis, right? So suppose if you're doing analysis after third speed, now I won't increase. Suppose I won't increase here. There is no change in the input response. So still your fan will run continuously, right? So still, if the input response is 0, still your output exists because there is existence of initial condition. Now there is zero state response. I'll explain what is zero state response, and you are going to learn what is forced response, what is controllability, and observability, right? Okay, so next, so what are the advantages? So advantages is that you are considering some initial condition exists, and you will get more accurate transfer function. And analysis will be with multiple input and multiple output will be less complex compared to your regular assumptions. So how you will write your outputs? Outputs are y1 and y2. So it is dependent on u1, u2, x1 and x2. So I'll take with respect to initial condition. So here I am multiplying with x1 with one constant and x2 with some other constant. Okay, and this again u1 and u2 will be multiplied with the different constants labeled as d1 and d12, right? So similarly for y2, you'll be, since it is dependent on the initial condition as well as your inputs, so I'm writing with c21, c22, d21 and d22, right? So I'm writing these things in the form of matrix, right? How I'm representing? So this is your y matrix, this is your total. Okay. One more thing. See here, this is u1 and u2 are your inputs, multiple inputs, that is 2 inputs, and y1 and y2 are your outputs, right? And x1, x2, these are your initial conditions. These are your initial conditions. You know, so I taught how to represent this y1 output in terms of the inputs and initial conditions. Now, from this, I'll convert this into matrices. So y1 and y2 are my output. So I written as y1 and y2 in the as a column matrix. So it is 2 cross 1, and here this all the constants of with the initial conditions C11, C12, C21, and C22 are written as one matrix with initial condition x1 and x2 plus one more matrix as with the respect to inputs D11, D12, D21, and D22. So this is my D matrix with inputs as U1 and U2. So finally, you will be getting an equation like this. Okay, y of t. This is in time domain, not in Laplace. So in order, as I taught in the previous class, so solving in time domain, it's very difficult. The control solving a control system in time domain is very difficult. So we will convert it into Laplace transform. We'll convert it into Laplace domain. Then we will solve in the Laplace domain. If you want final output in time domain, again we'll convert this Laplace transform into the time domain, right? So now this is your first equation, that is y of t is equal to cx of t plus du of t. So anyone, so did you write down this equation? Y of t is equal to cx of t plus du of t?
Yes, sir.
Yes, sir.
Done? Okay, so we'll move on to second equation. So okay, see this x of x1 of t, right? So it is written in terms, see this is dependent on, see this is x cap of t, this is called differentiation of your initial conditions, right? So for this, see, if I write x dot of s, see this is in time domain, but if I'm writing in Laplace domain, this will come as x dot of s. So for this, I need to write s x of s minus x of 0. So this is one more formula that we are using, that is x dot of s. Any differentiation, if it is there, we are taking x dot s dot of s minus x of 0. So I hope everyone has learned signals and systems. Signals and systems. Everyone has learned. So in signals and systems, for differentiation, you will always multiply with s. For integration, you will always multiply with 1 by s. I think you might have learned in your signal systems. So here is your differentiation, right? X dot of s, right? So when I convert it into Laplace, it will become x dot of s. For x dot of s, it should become x s of s, right? X s of s, correct? Because this is differentiation, I'm so for differentiation I need to multiply with s, so it will become s x of s. So since it is 1, so if I want x1 dot of s, I will be writing x1 of s, right, minus x1 of 0. Why I have written x1 of 0? Because in the previous modules, you assumed your initial condition as 0. Right? When initial conditions are 0, x1 of 0 will be equal to your 0. So whenever we are writing in the previous modules, I used to write if x dot of s is there. So directly I was writing x s of s, right? Because initial condition was 0. If initial, here in the state transfer space analysis, where there is some initial condition, so I need to include that initial condition. So that is expecting as minus x of 0. Understood the basics now? So can you tell me how you are going to write x2 of s? So this is be written as x2 dot of s. A dot indicates differentiation, right? So if it is double differentiation, you need to put 2 dots. If it is triple, you are putting 3 dots. Okay, since you are using only one level of differentiation, one first order differentiation, so we are putting only a single dot, right? So what is x2 dot of s? How you are going to write? The writing as x s2 of s minus x2 of s. The x2 of 0. This is my initial condition. So x2 dot of s is equal to s into x2 of s minus x2 of 0. Initial condition is included, right? So similarly, when I write this, so I'll be getting this my third equation, right? So what is first equation? This is your first equation, y of t, that is output response. This is my initial state response, that is x dot of t. Okay, so this is your second. What is the third equation I taught? This one. This you need to write. So all of you write these three equations. Right. First one was this. I hope this you are written. So second you copy down this, and third will be this. So these three are enough for solving your problems. And you need to know the basics of matrix multiplication, how to take inverse of that, and how to write adjoint matrix, right? So it is here in your syllabus, engineering syllabus, you are only having 2 cross 2 matrix, not more than that. So you are taking inverse, it will be pretty easy. I hope you know how, the shortcut how to take inverse matrix, inverse of a matrix within without much calculation. So did you write this?
Yes, sir.
Done. Okay, anyone has any doubts till here? Okay, so no need to learn. Okay, so this and all no need, because see, I see no need to remember this. As you know, if it is 2 cross 1, right? So the second matrix should be 1 cross something, right? You know the basic rules of matrix. We will learn slowly when I'm dealing with problems. Then we'll cover this, right? So now, okay, so this is how you'll write signal flow graph. I'll take it slowly. So this is if transfer function is given to you, right? So this is your transfer function, y of s divided by u of s, right? Here it is no x of s. X of s is represented by initial states, right? So the see here output will be your, this is your y of s if I take, and this will be your u of s inputs, right? So this is your u of s, right? So that's why your matrix is y of, okay, it should come capital because this is another domain, right? So it should come as capital. So v of y of s by u of s. So this is your transfer function, right? So now I need to solve this. And finally, I need to write signal flow graph. So how is your signal flow graph? So this is your signal flow graph. Okay. So shall I teach how I have written this, or how it has come?
Yes, sir.
Okay. So now, see, here there are terminals x1, x2, or basically they'll ask in this way. See, basically they won't ask you to convert from transfer function to signal flow graph. They'll ask in the reverse way. They'll ask, they'll be giving signal flow graph and they'll in this way. Okay, fine. So I'll take a try. Or first we'll cover in this way. First we'll take signal flow graph, then we'll come back to transfer function, right? Okay. If you want, I'll teach once. So now, see, this is your transfer function. Y of s is your output. U of s is your input, right? So now, which is your, you need to solve this signal flow graph. So see, whatever is in the numerator, see, this is your zeros, right? And these are your poles, right? So now, see, always, see, and this is in negative sense. It means you are writing as a feedback, right? See, always your as you know, what is the formula of your closed loop transform? G of s divided by 1 plus g of s into h of s, right? So now, see, when I am writing, the first always, this is a basic thing. First, from here, this is your u of s. First, I will be writing 1 by s, 1 by s, 1 by s. This is my first step, right? So when I'm writing, here I'm writing 1 by s. I'll be taking one point, and here I'll be writing 1 by s, and here one more thing, I'll be writing 1 by s. Why I have written 1 by s? Because the order is s cube, right? So s cube means what is your final 1 by s into 1 by s into 1 by s? It will become 1 by s cube, right? So now, what is your first thing? See, for b naught, there is no multiplication of 1 by s, right? So what I'll do, I'll directly connect it to the output like this. It's clear now? Got it? See, all zeros will be going in the forward direction, poles will be coming in the reverse. Means the arrow indication, right? So now, okay, I hope you understood b naught now. See, b naught, there is no, what do you call, no s term that is getting divided, right? So I'll directly connect from my input to the output as my b naught. Now next is my b1. b1 is multiplied by 1 by s, right? So where is my 1 by s? So from here I'll take it, because see, if I go forward, if I take it at the second one, or if I take from the first one, it is getting multiplied by 1 by s into 1 by s into 1 by s, right? It is getting multiplied by 1 by s cube. But here b1 is getting multiplied by only 1 by s, right? So I need to take only 1 by s. So I'm taking from here till here, right? One point I have taken. So I'm taking from input till this point, because I want only 1 by s, right? So from here it will go like this, because here I am multiplied with 1, so this will come as multiplication with 1 by s. Here it's clear, guys? Any doubts? Yes or
No,
no?
sir.
No, sir. No, sir.
No doubts, right? Okay, now coming to the b2. b2 is getting multiplied by 1 by s square, so I need to have two 1 by s, right? So two 1 by s means I want this 1 by s as well as this, right? So both I can take. So that's why I'll come here and multiply like this b2, and I'll go straight, correct? So this 1 by s I got, and this 1 by s, right? So I have cleared till here. Now coming to the b3. b3 I need all the three 1 by s, right? So I'll take directly, correct? So it will become 1 by s into 1 by s into 1 by s. So till here it's clear. So I hope clear. Zero part. Any doubts here about b0, b1, b2 and b3? Always see, if it is okay, I won't make it complicated. Okay, so this is the way. Or if you want to write in terms of s, there is another way. See, here I am writing in terms of 1 by s. So what I did, I have directly take, what is the maximum term? 1 by s cube. So I have done multiplied with 1 by s, 1 by s and 1 by s, right? So there are, I'll take in between points, so that I can take 1 by s separately, 1 by s square separately, and 1 by s cube separately, right? Suppose if it is s cube directly, not 1 by s. So if you want to write directly, I can write as s, s and s, right? So you can take 3 points and you can do b0 will be coming here, which is getting multiplied with all the three, right? And b1 will be taking a jump from here, and it will be going like this. Sorry, it will be going like this, and b2 will be going like this, right? And b3 will go directly. If I take s, if I'm taking 1 by s, 1 by s, so it will change. Understood now?
Yes, sir.
Okay, so now what about the a1 by s? See, a1 by s, I want in reverse direction, right? Because it is a 0. So I'll be taking here a1 of s. a2 is getting multiplied twice with the 1 by s. So it will be coming like this, and A3 as 1 by S cube. Got it? See how A3 is getting multiplied thrice? Anyone has any answer for this? How A3 is getting multiplied by 1 by S cube? See here, A3 is getting multiplied by 1 by S cube, right? But here I have taken only 1 this way. How it is getting multiplied by 1 by S cube? So minus is clear. Minus is here. So I have compensated with this minus. Done. Right? So where is this 1 by S is this 1 by S into 1 by S into 1 by S, right? So it is becoming 1 by S cube. Similarly for A2, see A2 when I take like this, it is again multiplying 1 by S and 1 by S. So it is becoming 1 by S square. Understood now? I hope it's clear how to draw the signal flow graph if a transfer function is given, right? Okay, so how to write the equations for this? So first task is done. What was the first thing? Block diagram, transfer function you can write. So if block diagram is given, you can write signal flow graph, and if signal from the transfer function, you can bring block diagram. From block diagram, you can convert to signal flow graph. From signal flow graph, you can write transfer function. No issue, even if it is multiple input, right? So now how to write your standard equation. So these two were your standard equation. Y of t is equal to Cx of t plus du of t. X dot of t is equal to Ax of t plus Bu of t, right? So now, what is your y of t? So this is in time domain. Sorry, this is in Laplace domain, right? So what is your finally y of s? So as you know, where is your x1, right? So now, what is your y of s? Y of s I can take like this. Right? So y of s is b naught into y of s is equal to b naught into your u of s. It's clear now? And plus there is one input from x1. So x1, x2, x3 are initial conditions, right? So is it clear how we are written y of s? So this y of s is equal to x1. That is this. From here, one arrow is coming. See, other arrows are back, feed forward. That is backward, right? Other three arrows are backward. Only two arrows are forward, right? Previous, where it is getting multiplied, u of s. So b naught into u of s plus your x1, right? So I'll take one more, x1 of t. So x1 of s. So how you are going to write x1 of s? X1 of s means this point. How many forward paths are coming? This is one forward path, right? For x1 of s. So how you are going to write? And there is one more path that is coming to x1 is this. Totally 1, 2, and 3. Correct? So one is this. So all are getting mixed up and coming to x1. So how you are going to write? X1 is equal to a1 into x1. Okay, this I should teach. Okay, so see, one more thing. This should be your x1 of s. Okay, so no, I won't make it complicated. When problem comes, it will be pretty easy because it won't be so much complicated. Okay, when problem comes, I'll teach this. So no need to worry. So we'll start with this equation. Zero input response. Zero input response means in this equation, I need to make input as 0. So which is the input here? Input vector. Whether it's x dot of t or y of t, x of t or u of t. Which is your input vector? Zero input response means you are making input as 0.
U of t, sir.
So u of t is my input, right? So here u of t means I need to make u of 2 as 0, both the sides. So when I make u of t as 0, what will be your x dot of t? X dot of t is equal to ax of t, y of t is equal to c of x of t. So these two equations I'll be getting, right? When I make u of t as 0, that is 0 input response. See, most of the case, there are many cases that u of t will be 0. Okay, while you are solving gate problems, you'll come to know. Next, for this, I'll take Laplace transform. So for x dot of t, what I said, for x dot of t, what is the Laplace transform? X dot of t is equal to x s of s minus x of 0, right? So for x dot of t, you're writing x s of s minus x of 0. A remains same, x of t will become x of s, right? So now again this x of s will go left hand side and x of 0 will go right hand side. So finally I'll be getting this x of s is equal to x si minus a inverse x of 0. So it looks complicated too, but it is pretty simple when you solve problems. The S is a matrix. So how you are writing S matrix? So Si. So Si is a matrix, right? A is a matrix, correct? A is a matrix as I have shown here. Where is that? So A is a matrix, correct? A1, A2, A21 and A22, correct? B is a matrix. Since in the 0 response, this will become 0, right? So B won't be coming. Here also U of t is 0. So C is one more matrix, C11, C12, C21, C22. So here Si, A is a matrix, so Si should also be a matrix. So how you are going to write Si? So I is a identity matrix. So S will be S, S, S and S. This is 2 cross 2 matrix into, how is identity matrix? 1, 0, 0, 1, right? So when you multiply both, what you will be getting as output? S, 0, 0, S. So this is your Si matrix, that is S0, 0, S. So you can write this formula as your fourth one. While solving problems, you need x of s is equal to Si minus A inverse. This is a matrix into x of 0 is also a matrix. So here Si minus A is called as inverse is called as your straight transition matrix. So whenever they may ask state transition matrix, so you need to solve Si minus A inverse into x of Si minus A inverse. That's it. Did you copy this? Fourth and fifth? You're copying? I'll refresh it once. Okay, so this is your fourth and this is your, so this is called as your statement. While solving problem, if you know the matrix, it won't be difficult to you. So now coming to the y of t, this is my output. So when I take Laplace transform for this, what I'll be getting, y of s is equal to c into x of s, right? So x of s you can find here and substitute here. That will also do the job, right? So when I substitute here, c into si minus a inverse x of 0. I hope you have copied this fourth and fifth formula. Guys?
Yes, sir.
Done. Okay. Okay, so in forced response, okay, I won't go in detail of forced response. Okay, so you can solve, see, whatever is there in this way, when a problem is given to you, you can solve in 2 minutes. It won't be much complicated. Okay. So here what will happen, if any input is applied to system, what output they are getting, that is forced response. It means input will be there, your initial conditions will be there, your output will be there. All the three will be there. What response I'll be getting, that is called as forced response. So we'll solve problem on that so that this will be clear. No need to learn the derivation. The next thing is controllability. We'll solve problem on this. There won't be any difficult for you. So controllability, what is controllability? It is usefulness of the state variables. Here in controllability test, we are going to find whether a state variable can be controlled to achieve the desired output. Means if I control my control system, right, whether my desired output is being achieved or not. So if there is equation for this, that is this is my equation for controllability. This one. So B, they won't be writing colon. Colon means you are writing side by side. This is a matrix you'll be getting, controllability matrix. That is B, AB, A square B. Like that it goes on. But here in your syllabus you are having only 2 cross 2. So you'll be getting B, AB, only 2 terms. It means, see, if QC becomes 0, if QC is equal to 0, when I solve the matrix, if this becomes 0, then we will conclude that my control system is not controllable. I can't able to achieve my desired output. If QC is not equal to 0, it means I can achieve my desired output. Got it? So what is B? See, B, as I had told in the equation, so B is this term, the matrix in the initial conditions. Got it? A is the matrix when you're multiplying with the initial conditions, and C is with the initial condition in the output section, and D is with respect to the inputs. Okay, so I hope it's clear. We will solve some problems. So you can copy down this. This is your 5th formula, and observability is your 6th. So what is CT? CT is the transpose of the matrix. C is one matrix, right? So y is equal to C into x of t plus d into u of t, right? So you need to take C transpose. This is the first column, and A transpose into C transpose. This is my second column. Totally 6 formulas done. So you can go for the gate problems. Okay, so I'll revise once. Okay, so what is controllability? So in order to do whatever we want with the control system, it finally means if I want my desired output, whether it is achievable by my control system or not. So that is my controllability. So if I apply my output, whether I'm getting my desired result or when I apply my input, whether I'm getting my desired output or not by controlling some functionality, that is called as controllability. Observability, what is going on inside the system under observation. So that is called as the observability. So this it will come in BIST concept. BIST concepts you are not having. Okay, I'll take 2 seconds. Shall I explain the what is controllability and observability? I'll just give the basics because using definition you won't understand much. Take a whiteboard. So see, that's not really. It's too much. So I'll give basics of what is controllability and observability. Okay, now suppose a person will come to you. Okay, suppose you have a washing machine in your home, right? So now, suppose if it goes bad, and it is not working properly. So whom you are going to call? You are going to repair by yourself, no, right? See, what your washing machine will be having functionality. One functionality will be pumping the water or sucking the water. Other one will be rotating the motor, and then third one will be the rinsing, right? So I'll assume these 3 as my inputs to the washing machine, right? That is, first input is water supply, and second one is your rotating of the motor. Third one is the that is rinsing as or soaking, right? These 3 are the functionality. So soaking may come as output. Fourth one, so this is my two inputs. So two outputs will be soaking and throwing the water out, right? So now, if this any of the functionality goes bad, what you are going to do? The main company person will come. Whether he'll check all the things, he'll check only the circuitry, right? So in the circuitry, what will be there, right? So in the circuit, suppose there are four parts in the circuit. First part is for water intake, second part for the rinsing, third for the soaking, and fourth is my final output, right? Final output. Now, so what your person will come and do? What your person, the company person will come and do? He'll give inputs. He'll just give the input combination. So there are four inputs. So if I assume only four inputs, so totally there are 16 combination possible. 0, 0, 1, 2, all the four ones, right? So what he'll do, he'll give all the 16 combination. For these 16 combinations, he'll be previously knowing outputs. See, for 0, 0, 0, I need to get output as 1, 0, 0, 0. For all the ones, it should be 1, 1, 0, 0, something like that, right? So now for particular combination, you want to be getting correct output. So what it indicates, something has gone wrong, either in the rinsing or in the soaking, right? So next what he'll do, he'll either repair the chip. Okay, so if all the outputs are wrong, then what he'll do, he'll replace the whole chip, right? Suppose if that is controllability. Now observability, suppose only a specific part has gone wrong, right? A specific part has gone wrong. So how he can give the inputs and he can check like a particular part has gone wrong. Suppose there is no chance of checking the output, intermediate output. If you are a very old machine, right? If your machine is pretty old, now he can't able to check intermediate output. So what the guy will do? He'll bypass this. He'll bypass here. There is bypass mechanism. Like he'll be giving the combinations, and he can bypass and he can check individual output. So this individual checking of output is called as your observability. Can check or observe the output whether it is correct or not. Basically, what is observability? He'll give the inputs. He'll be you are giving the inputs and you are checking the output whether my desired output is coming or not. Okay, so no need to waste time on that. Okay, so I'll revise once. So state transition matrix is Si minus A inverse. Transfer function, you can copy down this transfer function. This as my 7th. When you are solving problems, this won't matter much. You can use the formula of this y of t is equal to cx of t plus du of t, and you can solve. So controllability is b, ab, a square b. So you'll be 90% you are using b and ab. What is AB? A is matrix and B is another matrix, right? That is x dot of t you are written as Ax of t plus B of t, and observability is C transpose, and this is first row as C transpose, and second column is A transpose into C transpose, right? So I hope it's clear till here. We'll be solving some problems based on this. Okay, so coming to they are asked the time response of this, or suppose can you calculate state transition matrix for this? What is a state transition matrix? I said that is Si minus A inverse. Okay, I'll explain you this problem so that you can solve the further problems, whatever is there. So now so coming to the state transition matrix. So now, see this. What is your equation of your? What are the equations of your state space analysis? One is your x dot of t as A x of t plus B u of t. All right. So now second one, y of t is equal to C x of t plus D u of t. Okay, so these are their equations. Now If I want my transition matrix, suppose if I want my STM, that is also called as STM, that is state transition matrix. So what is the formula? That is SI minus A inverse, right? So it may be asked in time domain or in Laplace. If it is asked in time domain, you need to take Laplace inverse of this because S is already there. It indicates it's in Laplace domain. So if they ask in time domain, you can take Laplace inverse of this. They ask in Laplace domain, you can keep it only Si minus A inverse. So now, I taught what is Si, right? So can anyone tell what is Si matrix? What is the output?
Yes, 0, 0, S.
So it is S0, 0, S, right? Next, Si I got. Now what is A? A is already given as 0, 1, minus 2 and 0. So subtract this. 0, 1, minus 2 and 0. So what you will be getting? Si minus A. So S minus 0, so you'll be getting S. 0 minus 1, you'll be getting minus 1. 0 minus of minus 2, you'll be getting 2. And S minus 0, you'll be getting S. Right? So till here it is clear. Right? Any doubts here?
No, sir.
All right. So see, I want in between some response so that otherwise, see, I forgot to record. I kept, but it didn't start. So these situations will happen, and sometimes audio might not be clear, right? So if in between, if you give a response, it will be helpful for me. So now how? So this is your SI minus A. How to take inverse? Do you know any shortcuts? Guys, for 2 cross 2 matrix, this is your 2 cross 2 matrix. What is the shortcut? Now, see, interchange these two. Interchange your first and fourth. Interchange first and fourth. How to take inverse? Interchange first and fourth, and second and third. Whatever is there, you interchange the signs. Got it? So this signs should change. Means whatever signs this person will be having, that should be transferred to the this guy, and whatever this guy has should be transferred to the other one, right? So what you will be getting finally? Can anyone tell me what is the Si minus A inverse? If you do all circles, adjoint, everything, this is the basic shortcut you will be getting. So what is there? So okay, I'll change it. Okay, I hope you understood how to take inverse, or shall I repeat? Because everywhere you are dealing with 2 cross 2 matrix, so you should know these basics. Understood? So if any 2 cross 2 matrix is given, these two should be interchanged. Means suppose if it is 1, 1, 2, 3, 4 matrix, right? If they ask you to write inverse of this, so how we are going to write? Suppose this is minus 2, 1, minus 2, 3 and 4, right? So you need to interchange 1 and 4. So 4 will come here, 1 will come here, and 2 and 3 position remains same, but sign will interchange. So this minus 2 sign will come here. So this is the inverse matrix of the first one. 1, minus 2, 3 and 4. Inverse will be 4, 2, minus 3 and 1. Understood?
Yes, sir.
So why today you had more workload? Nowadays, not so much enthusiastic.
Sir, we should divide by the magnitude, no, sir.
No. Everything you solve and tell me. This is your final answer. You can try. You find inverse of this 1, minus 2, 3 and 4. I'll give 2 minutes time. Find inverse of this, you'll be getting this answer. Done?
No, sir, it is only for the adjoint
We
we
are
have
supposed
that
to
formula.
divide by the determinant, right?
Oh, sorry. I need to, okay, determinant I need to divide it. Okay, sorry. So it should come as 1 divided by 4 into 1 minus, sorry, 4 into 1 plus 6. So it will be 1 by 10, right? Okay. The upper adjoint I wrote. Okay, sorry for that. Thank you. So it will be 4, 1, 2, and minus 3. So it will be 1 by 10. Similarly, when you write for this, how you are going to get? So S and S remain same. So this will remain same. This will become minus 2 divided by the determinant. That is S square plus 2. Right? So we're getting this. We'll be getting finally as S divided by S square plus 2, 1 divided by S square plus 2 minus 2 S square, and S divided by S square plus 2. Right? So now coming to the gate questions. First we'll solve the before easy question, then we'll come back. So now I told using this state space analysis, you can determine your this one also, stability also, right? And you can define whether the system is underdamped, undamped, critically damped, and overdamped. Right? So now how to write this equation? Okay, so can you so what how you so you need to write in terms of your matrix, and you need to tell whether the system is undamped, underdamped, critical damped, and overdamped. Right, so how to write this equation? So what is this d by dt of x of t? I can write as x dot of t, x1 dot of t, correct? Yes or no? And if I push x2 that side, I can write as x1 dot of t is equal to x2 dot of t. Sorry, x1 dot of t is equal to x2 of t for the first equation, correct? Yes or no?
Yes, sir.
Right? So how you are going to write second and see? So okay, I'll first explain the problem. Okay, is the question thorough to you? What to be done, how to proceed, you understood? Or suppose this question is given to you, how you are going to proceed? So now, in the previous classes, what I taught you, how to, okay, so can anyone tell me how to find whether system is undamped, underdamped, critically damped, or overdamped? I taught in the class while taking time response. We are having somewhere in the second order function what I taught, omega n square divided by s square plus 2 zeta omega n plus omega n square. So this was second order transfer function, right? So zeta used to define your transfer function, right? Sorry, zeta used to define whether system is undamped, underdamped, critically damped, and overdamped. So if you don't want, I'll revise once. I hope it is there. No. Okay, it's not there. I'll clear it here. So I think okay, you didn't make notes. I don't know if poles are repetitive. If it is lying in imaginary axis here, it is undamped, right? It will be here undamped. Explain, right? With the figure.
Yes, sir.
And here it will be underdamped. If they are complex conjugate, it will be undamped, right? And if they are roots on the negative real axis, it will be critically damped. And if they are negative real axis same roots, it will be over damped. I think I have explained, right? So this was based on the zeta value, right? So now, so I need to find and convert the equation in such a format like omega n square divided by s square plus 2 zeta omega n s plus omega n square, right? It means what was this? This was a transfer function, right? So for transfer function, what is the input here? R of t, right? R of t means denominator should come as R of s What is the output? Output is C of t. So output, it should be, a transfer function should be C of s divided by R of s. I need to find, or I need to derive I need to solve this, and I need to get C of s divided by R of s, so that it will be converted to this form, and I'll be getting my zeta, and zeta will tell this. See how here they are going to mix the questions. This is a speciality of the GATE exam. There is a speciality that they'll mix the questions. Okay, so I hope how to approach of the question you have understood. Any doubts here? How to approach? I'll solve the problem, no issues. So you need to find the zeta value, right? So zeta, as you know, that is defined by the transfer function. That is omega n square divided by s square plus 2 zeta omega ns plus omega n square. So you see, this is, you are solving for first time, so you'll be facing difficulty, no doubt. See, I solved almost some 20 or some 50 times. I'm thorough in this, right? So so what is your transfer function? It is usually C of s divided by R of s in this problem, right? C of s is the output given, and R of s is your input. It is given here, right? So what is your C of t? C of t is given as your x1 of t. So I can write in Laplace s of s as x1 of s. It is clear here. Any doubts? C of s is equal to x1 of s. It's thorough here.
Yes, sir.
Okay. So now this is your first. So coming to the first equation. The first equation, how you are going to solve? I told, if it is differentiation, I am writing with one dot. Correct? So this term d by dt into x1 of t, I am writing as x1 dot of s. Right? It's clear. X1 dot of s. I am converting to Laplace directly. Now, what about x2 of t? How you are going to write Laplace for this? You are going to write as x2 of s. Since this I'll push on to the right hand side. So x1 of s will be converted to x2 of s. Clear? x1 of s is equal to x2 of s. It's clear now? Till here, any doubts? Guys?
No, sir.
No, right. Okay, now coming to the second equation. This equation. So how to write in Laplace domain? So as I told, d by dt into x2 of s, you can write as x2 dot of s, right? So first part I have written as x2 dot of s, correct? So now next part, plus 2 x1 of t. So I can write as 2 into x1 of s. I am converting to Laplace domain, because in Laplace domain your calculation will be pretty easy compared to your time domain. So 2 into x1 of s, no doubt for this, right? Next, plus 3 into x2 of s, correct, is equal to your r of s. Is it clear here?
Yes, sir.
Clear, right? Now, what is given x2 of s? So what I told for x2 of s, how to write, and any initial condition is given here? No. So initial condition is not given. Okay, we'll solve. So x1 dot of s is x2 of s. Next, x1 and x2 are two state variables. So what I want for my final answer, C of s divided by R of s, right? So x1 or so now, if see here, initial condition is not given. So for time being, I'll assume initial condition as 0. So x2 dot of s, how can I write? Okay, before that, I'll do some conversion. Okay, so x2, okay, x2 dot of s, how can I write? I can write s into x2 of s, correct, minus x2 of 0. This was a formula I told you to write. x2 dot of s, that is differentiation of this, is equal to s into x2 of s minus x2 of 0, since it is dot here, correct, plus 2 into x1 of s, correct, plus 3 into x2 of s. Okay, either you can convert to all, see, what is the thing? See, either you should convert everything to x2, or you should convert everything to x1 terms. Oh, okay. Okay. See, there you are using only two formulas here. Only one formula, that is, if it is x dot of s, you are going to write as x of s. Initial condition is assumed to be 0, so you can put this x of 0 as 0, right? So I'll solve once. Okay, so 2x1 of s plus 3x2 of s. So what is your x2 of s? It is x dot 1 of s, right? Is equal to your r of s. Is it clear till here? Any doubts? Or you are solving? Guys, you are there?
Yes, sir.
You are solving on your own.
No, sir,
Trying,
listening, sir.
You are listening. Okay. So what is the next step? It's pretty easy. So here is your x2, x2, x1, x1 dot, right? So here, see, finally you want c of s divided by r of s, right? So what you got?
Yes,
Okay,
sir.
till here it is clear. S into x2 of s minus x2 of 0 plus 2x1 of s plus 3x1 dot of s. It's clear till here?
Yes, sir.
Correct. Okay.
Yes, sir.
Now, what you want? You want everything to be in terms of x1 of s, right? So x2 of s, what is there? x2 of s, again I can write x1 of s, right? Okay, this is 0 because there is no initial condition. See, x2 of s, I can write, see, x2 of s is equal to x1 dot of s, right? So I can write s into, okay, s into x1 dot of s, right? So this is 0 plus 2 into x1 of s plus 3 into x1 dot of s is equal to r of s, correct? Any doubts here? x2 of s I have
No,
replaced again
No,
with
sir.
x1 of s, right? So now again replace x1 of s with this. So how we are going to replace x1 of s? What is your x1 of s? x1, sorry, x1 dot of
S
s,
into x of 1 of
correct?
s.
So it will be x into s1 of s. So initial condition is 0, so no need to write. So x1 in s into x1 of s. So what your first term will become? First term will become as s
S
square,
square into
right?
x1 of s.
So okay, so s square plus 2x1 of s plus 3s into x1 of s, right? Got it? So first term will become s square. Is that? So first term will become s square. Second term will be constant as 2. Third term will be 3s. Got it? So what will be your denominator finally? What will be your r of s? R of s will be equal to x1 of s into s square plus 3s plus 2. Till here everyone got r of s is equal to x1 of s into s square plus 3s plus 2. Anyone didn't get till here? So you need to get r of x1 of s into a square plus 3s plus 2 is equal to your r of s. What is your c of s from here? C of s is equal to x1 of s. So what is your c of s divided by your r of s? Both side x1 will cancel. So what will be remaining? 1 divided by s square plus 3s plus 2. Something is going wrong. Okay, it is 1, but it should come. Okay, so this should come as your r of s. No issues. Sometimes it happens. Okay, so what is your zeta here? What is your omega n square? Omega n square is equal to 2, so omega n will be root 2. So second term will be 2 zeta omega n is equal to 3. So what will be your zeta? You can solve like this. So we got till here, right? R of s divided by s square plus 3s plus 2. I think you got till here, till this point. So this is a solution. They have directly skipped everything and solved. So I solved step by step. Guys, it's clear? Or shall I repeat?
Got it, sir.
Got it? Ashwini,
Yes,
Tushar,
sir.
Uday.
Yes, sir.
Got it? So what you got? S square plus 3s plus 2. So omega n square is
But
equal
why
to.
is it overdamped?
Okay, I am telling that one. So omega n square is equal to 2. 2 zeta omega n is equal to 3. So zeta will be 1.5 divided by root 2, right? So what is 1.5 divided by root 2? So what is the value for root 2? It is 0.0, right? 0.707, right? If we take 0.5, so it will become double, so it will become 3. So zeta
Sir,
is,
1 by root 2 is
Sir,
0.707, sir.
1.414 is root 2.
oh sorry, so I need to multiply here, right?
Yes,
0.707.
sir.
So what will be zeta finally? When I calculate. So if I
Sir, we don't
calculate
have to calculate zeta, sir. We can directly tell no, sir.
so how much you are getting? 1.5 to 0.707. If I take as 0.5, it will become 3 by 2 into 0.5.
1.06.
So for 1.06, what is the zeta value? So overdamped, right?
Yes, sir.
Right? Zeta greater than 1. It is overdamped. I think I have shown one more figure also, right? Okay. So, okay, you should keep revising. Okay, so I hope this problem is clear. If you solve some another 1 or 2 times, it will be clear for you. No doubt in that. Say, after one semester you are doing and you didn't write exam also, so you may face a little bit difficulty. But once if you practice few problems, it will be thorough. Problem I wrote solution also. So what is asked? They are asked y of t. So what is representation of the system? Is your x dot of t, and they are given matrix as. So what is your x dot of t formula? You are having a into x of t, right? Plus b into u of t. So b into u of t is not there. What does that mean? Here input response is 0, right? It is the example of 0 input response, correct? So what is your y of t? Y of t is equal to c into x of t plus d into u of t. U of t is 0 again, so it is 0 input response. So this you got. Now we need to find what is y of t, right? So we need to indirectly find 0, 1 is already existing. So you need to find x1 and x2, right? So now for that sake, see x1 of t and x2 of t, this is your x of t matrix, correct? So for x of t, what is the formula? I think I have given what is x of t. This is your formula. Because see, this is 0 input response. For 0 input response, what is your u of t? U of t is 0, right? U of t is 0. Yes or no? I hope you have written this formula, right? So for u of t is 0. So this problem is u of t is 0. That problem is based on 0 input response, right? So you need to use this formula to find x of s. After finding x of s, you need to convert to time domain and multiply. Or okay, as you know, multiplication in frequency domain is convolution in time domain, right? Something like that. So no need to do. We will multiply in Laplace domain only. So this is a formula Si minus A inverse into x of 0. So x of 0 is given. This is done. Okay, this will go. So now y of t we need to find, right? Y of t is 0 into 1 into x of this matrix, right? So what is your x of t matrix formula? That is Si minus A inverse into x of 0. So x of 0 is already given as 1 and 0, right? 1, 0. So I need to find xi minus A. So this matrix is your A, 0, 1, 0, minus 1, right? So can you multiply and tell me? So what will be your Si minus A matrix? What will be your Si minus A? So Si is your S, 0, 0, S, 0, 0, S, minus A. A is your 0, 1, 0, minus 1. Correct? So when you subtract, what you are going to get? Yes, remain same. This will become minus 1. This will remain 0, and this will become S my plus 1. Everyone got this? Si minus A. Till here, is it clear?
Yes, sir.
Right? So can you find inverse for this? Inverse what you will be getting? So this remains same. This position I need to interchange for getting this one. So when I write inverse, this will become plus 1, and this will remain yes, and this will become plus, right? So it will become s plus 1, 1, 0, and yes, right? And divided by your determinant, that is s into s plus 1. When I take Si minus A inverse. Till here it's clear. So what is your x of s formula finally? X of s is your Si minus A inverse into your x of 0. So Si minus A, I hope you got till here. 1 by S into S plus 1 into S plus 1, 1, 0 and S, right? What is the X of 0? X of 0 is 1 and 0, right? So when you multiply, you are getting answer as 1 by S. Can you solve and tell me whether you are getting same answer? I hope you have learned matrix multiplication. So it
Yes, sir, I got the same, sir.
making any mistake. Bharat, biscuit and garden. Everyone got this? 1 by S and 0.
Yes, sir.
Sure.
Anyone didn't get? Right? So finally, what is your conclusion? What is your final answer? As you know, y of t is equal to d into x of t. U of t is 0, right? So y of t is given as, you can multiply in Laplace. Y of s, okay, this should be capital. Y of s is equal to d into x of s. What is given as d? 0 and 1. So 0, 1 here, and x of s is 1 and 0. So when you multiply, what you'll be getting? Sorry, not sine of t. You'll be getting answer as 0. Is it clear? Anyone has any doubts? This is just matrix multiplication. There are many inputs, right? Similarly, it happens for your image also. All the image is in the form of pixels. Finally, when they are solving, they are considering in terms of a matrix. This is matrix solution. Right? So is it clear? Anyone has any doubts?
No doubt, sir.
No, sir.
I need response. No, right? Shall we go for next problem? This is GATE 2018 question. So what is asked? See, see, whatever the formula I told you to write, I think I gave around 7 or 8 formula, right? It will solve all the problems of your state space variable, state space analysis. Almost 90 problems it will solve. But some problem, if they ask in signal flow to convert to your signal flow graph to transfer function, you may do some mistake, right? Okay, so state equation, the output equation of the control system are given below. So these are the equations. So this is your output and this is your initial condition. So you need to find, or you need to write the transfer function for the system. So what is your transfer function? So your output is your y of s, right? Input is your u of t. So you are basically solving y of s divided by your u of s. So can anyone tell me how your approach should be? Hmm? Guys, you wrote somewhere around 7 formulas, right? Out of 7 formulas, this applies. What is your first formula? First formula for your zero input response, right? Second formula, see here, zero input response means your u of t should not be there, but here u of t is there, right? So it means you need to use your full formula. What is your y of s formula or y formula? That is c x of t, that if I write in Laplace, c x of s plus d u of t, right? In the y it is 0, but if I take x of s, a, sorry, x dot of s, a x of s plus b u of s. So when I substitute, since this is 0, it's given here in the problem. So what will be your y of s? Y of s will be equal to c x of s. Correct? To substitute this x of s, this x of s, you need to convert and you need to put here like this. What is your c into xi minus a inverse in plus b? I should have showed you the formula. Where is that? This will be your x of s. See how I have solved. See, this will be your x dot of s, right? X dot of s. What will be your formula? See, this is your formula, right? X dot of t is equal to a into x of t plus bu of t, right? So when I convert into Laplace, this will become x dot of s, a into x of s, b into u of s, right? So what is your x of s formula? X dot of s formula? It will be equal to s into x of s minus x of 0. Correct? So this formula we are going to use. So when I solve this, same thing. I have used this x dot of s is equal to a into x of s plus b into u of s. Right? So when I push this x of s this side and do all the circles, I'll be getting x of s is equal to si minus a inverse into x of 0 plus si minus a inverse b into u of s. This will be your, I think, 9th formula. This is if it is a forced response. Forced response means input response is not 0. Neither initial condition is 0 nor forced response is nor your input is 0. Everything exists. So that time you will be getting forced response. That is x of s is equal to si minus a inverse into x of 0 plus si minus a inverse into b u of s. Suppose if initial condition is not given, then this whole part will become 0. So this whole term may become 0. So you'll be only left out with x of s equal to si minus a inverse b into u of s. So can you please copy down this also? This formula. Guys, done copying?
Yes, sir.
So we'll solve the problem. Okay, so what you got your y of s? Okay, so this is your y of s. I think si minus a inverse into x of 0. So what is x of 0 given here? X of 0 is not given. So x of 0 is assumed as 0 because it is not given, right? So now what is left out? Left out will be c into si minus a inverse into b, correct? So when I remove this part, in the okay, so if I remove this part, what will be remaining? X of s is equal to si minus a inverse b into u of s, right? So, and one more in the question, u of s is also not there for your output response. So c of s, y of s is equal to c into x of s. So this x of s you need to substitute here. What will be getting y of s? Y of s is equal to c into si minus a inverse b into u of s. Understood? Okay. So when you
Yes,
do
sir.
this, what you are going to get? Okay, so you will be getting this. So can you do multiplication and tell me what is your si minus a? Si minus a will be s minus 4. So a will be your minus 4, 4. This part will be your a, correct? This part will be your b. This part will be your c, right? You'll be getting this. When you do si minus a, you'll be getting s plus 4. Here will be your 1.5. This will be your minus 4, and this will be your s, right? When you take inverse, you will be getting this, correct? This will get interchanged, and there will be sign change of this. So you'll be getting this answer. Now next thing you need to multiply with b. Next thing you need to multiply with b. So b is 2 and 0. So when you multiply with b, you'll be getting this. So if you put here, see when I multiply this with 2 and 0, what I'll be getting, this remains same. So s into 2, it will become 2s. 1.5 into 0 is 0. 4 into 2 is 8. This will become 0. So I hope till here everyone got.
Yes, sir.
What about others? I think only Uday or Tushar is replying.
Yes, sir.
Okay. So now next thing what you need to do, you need to multiply with c. You want to multiply with c. What is c? 1.5 and 6.025. So when I multiply, I'll be getting 3s plus 5 divided by s square plus 4s plus 6. Okay. So moving on to the next problem. This is based on your controllability and observability. So can you solve and tell me this state transition matrix? Here it should come as dot. So it is asked. See, this is GATE EC 2014 set 4 question. This might be one more question. What is asked? You need to find state transition matrix phi of t of a system. So phi of t means you need to represent in time domain because all the answers are in time domain. what is given? X dot of t and x2 of t. So it is given as x dot of t, right, is equal to a into your x of s. This matrix is given. No input is 0 and output is also not given, right? So you need to find Si minus A inverse. This will be in Laplace domain, but it is asked in time domain. So you need to take Laplace inverse of this. This will come as your transition matrix phi of t. Can you solve and tell me? I hope it is easy. What will be your Si minus A? Si minus A will be yes, 0. So this will come as minus 1. This will be
Option D,
0.
sir.
Option D. Others? I have not seen option. What is it? Okay, so it is option D. You need to take inverse of this. When you take inverse, you will be getting 1 by this is S square, and this will become S 1 and 0. Right? So when you divide, what you'll be getting? We're getting as 1 by S. Here 1 by S square. Here it will remain 0, and this will come 1 by S. Right? So when you take Laplace of this, see 1 by S is Laplace transform of your unit step function, right? So unit step, when it was 1, you used to write 1 by S, right? For unit step, for your ramp, you used to write 1 by S square. If you remember clearly, I taught. So for your parabolic, you used to write 1 by S cube. So it is given 1 by S. So what will be your inverse Laplace transform? It will become 1. This will remain 0. 1 by S square is your ramp function t, and 1 by S is again step. So you'll be getting 1, 0, 0, t and 1. How many of you got this answer? Got it? This is one more question. See, sometimes if you are fair and your luck is good, you will be getting very easy questions in GATE also. Right? So coming to now this problem, we'll solve this, then we'll come to this. So next thing, what is given? They have asked whether system is controllable or observable. So what I said, if a system, I think for this, I think for controllable, I have given formula as B, AB, and A square B, right? So it is here, B, AB, A square B. For your observability, it will be C, CA, and CA square. Or you can write another way, as I have given here. It is given transport, right? So C transpose, A transpose, C transpose, like this it will go on, right? See here, A is with respect to n minus 1. So here C transport T remains same. Here also B remains same. It will become A square, A cube of B will be your next term. Here it will become A transpose T square C T. So it will become like this. So coming to the problem, so they asked controllable or observable. So you need to know this matrix B, A, B, A square B. And when coming to observable, it will be C, CA, and CA square, right? So now you need to multiply, and if you get answer as 0, like matrix, when you take determinant, we get as 0, it will be uncontrollable. If it is not equal to 0, okay, can you solve and tell me? So what is your A? Okay, here it is the 3 cross 3 matrix. This is your A, this is your B, and this is your C. This should be good in matrix multiplication. I hope it is easy multiplication because many are 0 here, 0 terms. So if you are getting answer as 0, it is uncontrollable. You can't control it. Means you'll be getting some random data, right? If you are getting it as Sorry, if it is equal to 0, right, it is uncontrollable. If it is not equal to 0 means you are having some positive value, then it is controllable. So can you solve for controllability? B, A, B, A square B, or I need to solve?
We can solve, sir.
Can solve, right? So B remains same. B is this. It is 0, 4, 0 remains same. So this first column remains same. A, B, A into B. So first minus 1 will be multiplied with 0, and this 1 will be multiplied with 4, and 0 into 0, right? So you'll be getting answer as 4 here, correct? Second one, only midterm is there. So you'll be getting minus 4, and this will be 0. So it is pretty easy. There is nothing great in matrix multiplication, right? Because many are 0 terms here, right? So when you take determinant of this, you'll be getting as 0. So first 0 is there. Next second term, if I take, it becomes 0, right? So you'll be getting determinant of your controllable function as 0. It means this is your uncontrollable. Uncontrollable means if I give certain input to achieve my desired output, I am not getting that because it is not controllable. It is behaving like a some other way, or like it's behaving like a mad, so that I'm not getting my desired output. So everyone got the determinant as 0.
Yes, sir.
Got it? What about observable? Ashwini, Uday. Uday answered or Tushar?
Tushar, sir.
Tushar answered.
Sir, sir, sir.
Yes, sir.
Got it, Ashwini?
Yes, sir.
What about observable? Should be C, CA, and CA square. See, many questions will be asked on this controllable and observable. If you search, every year minimum 2 marks will be for this. Out of your 10 marks, 2 marks will be maximum 90%. It will be on controllable and observable. Maximum. We can't solve some 15 to 20 gate questions in 2 hours, right? I need to teach some basics and solve it, and solve some questions, right? So I can't able to solve all the questions whatever is existing in the previous gate years, gate year exam, right? Observable is you got observable determinant as 1, right? So it is not equal to 0, so it is an observable. So what is the answer? Answer is B. It is uncontrollable because determinant is 0, and it is observable because determinant is not equal to 0. I hope it's clear.
Yes, sir.
Okay, and before that, I'll give some tips for the gate exam, right? So gate exam, see, you can't write all the formulas in a page. So see, your basic gate exam will be depth first, not the width. Depth first means, see, you are having totally 10 subjects. In your gate, you are having 10 subjects, including your aptitude, maths, reasoning. So first, basically, your maths will be your 15 marks. So if your target is of 50 marks out of 100 in GATE exam, if you want to attain 50 marks or 60 marks questions, I'm not telling correct answers. If you want to attain 60 marks, because you are doing part time, you are not totally dedicating for the GATE exam only, right? You're parallelly going, you're attending classes, you're doing mini projects and many things, right? So if your target is attending 60 marks, subject, don't learn all the subjects. See, aptitude and reasoning will be 15 marks. Your control system will come for 10 marks. Okay, and your I think digital electronics and your microcontroller will be for 5 to 6 marks, or it may go to 10 marks sometimes. If digital electronic questions are tough, it may go to 10 marks also. Okay, so next you can target your network analysis. Network analysis will be 8 to 10 marks. And your last one, you can learn little bit basics of signals. Plus you can learn AC, analog electronic circuits, right? Plus your EDC. EDC is electronic device and circuit components. So these two will come for 15 marks, AEC and your EDC. Nowadays, AEC, if they ask, these two will consist of 15 marks, and SS, if you learn, it will be asked for minimum 10 marks. If you learn basics, minimum you can attend 4 marks questions. You know basics, at least 1 mark question if you attend. 1 mark question get it will be easy compared to 2 marks. 2 marks will consume lot of time, right? So how many marks your thoroughness? 15 here. 15 plus 10 is 25. 25 plus if I take average as 5, so it will become 30 marks in this, right? So if you learn NA, you can cover another 10 marks as 40, right? And if you learn another 3, right, around another 15. If I consider overall, you can be targeting for 55 marks. You can touch 55 marks. Aram se. So many subjects you are left. You have left field theory. You have left your communication. If you are good in communication, you can learn. And along in digital communication, recently they are asking more on digital communication. Right? So if you are targeting for 1 mark question, you can purchase. So if you are with respect to communication, if you are good, you can learn basics of that. So you can at least you can touch for 2 marks, 2 marks here, and field theory some there. Only basics means whatever you know, make it thorough. In depth you should learn, not the width. Width means see no need to learn all the subjects, all the 10 subjects to clear. If you learn some 3-4 subjects, it's more than enough. Aptitude and reasoning, somehow you are learning in TYL, right? So control system 1 subject, digital electronics, networks, and AEC and EDC. Learn this. If your passing is your target, 4 subjects is more than enough to clear the exam. And plus you need to take one book called by the Made Easy book. That is a handbook for electronics and communication engineering. It will be helpful for your IAS, IES. It has all the formulas that is already existing. Already it is written, it is printed. That is mainly is a handbook, right? If you do this, you'll be get confidence. See, in a GATE exam, confidence is very 3 hours time. 3 hours time. Your target is to attend only. If your target is only to clear, you have to attend only 40 marks. The passing marks will be around 20, around 25. If it is OBC, it will be 23, and if you are SC/ST, it will be around 21 and 22. Right? So if you attend for 40, you can get 25. No doubt in that. Okay. I hope it's clear.
Sir, when will they release the cutoff marks, sir? Like before or after the exams?
Cutoff marks. See, since some how many years it has started. Okay, so they'll keep target as 25. If the paper is tough, see, for general it is 25 fixed. 25 maximum it can go to 26. That's it, not more than that. However, paper it might be easy. Your maximum it will be 26 only. Since some 20-25 years, it is in this range only. 25, 26, 24. In this range only. However, it might be easy. See, in I think 2018 and all, paper was very easy. Still, it is 26 only. It won't go beyond that because the paper, the level will be like that because it is set by the IITians, right? IIT professors. Particular, I think this time IIT Delhi is in charge of this, right? You can go through that.
Bombay.
Bombay. Okay, I think last time it was Delhi. So Bombay, right? So Bombay, see, you can go through the papers and see it will be in this range only. No doubt in that. Yeah, this will make sure it will be in this range only. 24, 25, 26 for your OC category. That is open category. General merit. If you are OBC, it will be around 23. If you are SC ST, 21. See, one time SC ST, the passing marks was 18 out of 100. That time your general passing was 23 and SC ST was 21. The paper was tough that time, right? So if paper is tough, your again the passing marks will your cutoff will reduce, become 21, 23 like that. Oh, if the paper is too easy, it will be 26 max, 25 to 26. If it paper is very easy, not more than it won't go more than that. I'm sure about that. Okay, so this is one more next question is with respect to your signal flow graph. I hope it's clear now how to approach your gate exam. Now coming to the signal flow graph. See, previously in the previous problem they had given directly this. Now they have given signal flow graph and they are asking whether it's controllable, observable, stable or unstable system. This is 2014 set 2. So if this is your question, so how to approach? See, always your matrix will be in this format. See, if it is 3 cross 3, it will be 0, 1, 0, 0, 0, 1, 0, 0, 1, and 1 second. I think it should be 3. I think it should be 3. Huh? 5-10 minutes. Okay, sorry. There are some disturbance. Okay, so it will be 0, 0, 1, and the third one will be your feedback. See here, if I so for example, see for your x1 matrix. So as you know, your transfer function will be in this format: x of s divided by your y of s divided by your x of s. So this will be your zeros and this will be your poles, correct? So for zeros, what I said, it will be the forward path, and for your poles, it will be in reverse or the feedback path, right? I hope in the previous problem I cleared this. See, in the transfer function, y of s x of divided by x of s, zeros will be your numerator, poles will be denominator. With respect to signal flow graph, feedback, this forward path will be your zeros and poles will be a reverse path, right? So now for x of s, what is their poles, right? Poles means you will be having feedback path, right? So feedback path you need to write. So when you're writing in the signal flow graph, it is always sure that it will be in this format. That is 0, 1, 0 and 0, 0, 1. If it is 2 cross 2, it will be 1, 0 and you will be having some numbers here, right? So if it is 3 cross 3, it will be 0, 1, 0, 0, 0, 1. Here you will be having your number or your alphabets. So always this will be your A1. First term will be your A3, second term will be your A2, and third term will be your A3. A1, like this. So these are some standards. While solving problem also, I'll tell there is one more problem here based on this one. This one. See here, they are given directly transfer function. In the problem that I showed, it was your signal flow graph. So now in order, so what is given in this problem, we'll solve this, then we'll go there so that it will be pretty thorough for you. So what is given state, so these are your equations. They have provided equations also. Y of t is equal to cx of t into du of t. ABC are the matrices. D is scalar. U of t is the input of the system. Y of t is your output. And B is given as your 0, 0, 1 transpose. D is 0. So D is given as 0. It means this part is not there. Which of the following are options for A and C will ensure that the transfer function is a LTI system? It is linear time invariant system. Okay, it won't vary with the time. So now see, for this function, how to write your a value. So as I have told, 0, 1, 0 will be here. Second term will be 0, 0, 1. Correct? Is it thorough here? See, all, if you see the matrix, see, this is also 0, 1, 0, 0, 0, 1. Here also 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1. It's clear now? This is a standard format, how you are writing. It's clear? Now, how to write this next values? The next,
Yes, sir.
see, next you need to write this. So, SQ, this -1 will be, negation of this will come. If it is -1, +1 will come, right? So, since it's +1, -1 will come here. 2 will become -2 and 3 will become -3. So, this is a standard how it is designed, right? So, it will be -1, -2 and -3. Similar in that problem also I'll show you. That's one feedback comes. It was like this somewhat. It was going like this. And third one was like this. This was your A1, I think. This was your A2 and A3. Right? That's why here it came A3, A2 and A1. Right? So when you write transfer function, 1 will come here, -1, -2 and -3. Right? So here also, so these two are wrong because -3, -2, -1 is there, but it will happen in reverse way. -1, -2 and -3. So out of these two, next. Now whether C is 100 or 001, right? So when you solve this, okay, so this is how it is written, 001, right? Okay, when you solve, you'll be getting this 100. Okay, I had solved, I kept sheet somewhere. Okay, see, you need to solve this transfer function thoroughly. You'll get this 100. Okay, so when you learn in depth, you'll be getting this 100. So no need to worry. I hope you understood how to find a value.
Yes, sir.
Yeah. So now this is done. Okay, so first problem is done. Second is done. This one is done. Fourth one is done. This one is done. This is remaining. Okay, this is done, right? So this is the last problem I'll be teaching. So for controllable, so how to solve this? This is a signal flow graph. As I said, 0, 1, 0, 0, 0, 1. So this A3 will be coming starting, A2 next and A1. Means whatever the feedback is here, A2 will come next and A3. Right? Now, and 0, 1, 1. How it is 0, 1, 1? See. What about C1? Right? So for this transfer function of B is given. With respect to Y matrix, C1, C2, C3, all the three are there. So C1 is there, C2 is there, and C3 is there. Now coming to your X dot matrix is your A into X of t plus B into U of t, right? Okay. Now when you take, okay, I'll explain this how you got 0, 1, 1. Give me a minute. Okay. Now when you get this, right? So how you so can you solve for controllability now? B, A, B, A square B. So A you got 0, 1, 0. So when you solve, you need to write B here, A, B and A square B. It is not equal to 0, so you got observability. And next thing is controllability. Okay, sorry, this it is not equal to 0, so it is a controllable system. And in observable also is not equal to 0 and it is dependent on this. So what is the answer you're expecting? Okay, so see, you got QC as 1 and your observability is dependent on some dependent variables A1, A2, A3. So now, okay, you got, okay, I'll write down your answer. You got controllability as 1 and observability was dependent on some variables like this. When you multiply this matrix, see, it is dependent on your C1, A1, A2, A3, C and the C terms, right? So now, out of these four functions, four options, which is more accurate? Can I take both? Okay, C and D are wrong, right? Because stability is not described here. So now A and B, how out of two, which is more thorough or more accurate? See what I said. If it is equal to 1, it is controllable, right? If it is not equal to, or if it is 0, then it is uncontrollable system, right? So when Q naught is equal to, it is dependent on the variables of A and C, right? So sometimes A and A and C can become 0, right? It can become 0, right? So it means it is not always observable, but your QC value is 1. It means it is always controllable. Got it? Why the option
sir.
B is wrong?
Yes, sir.
Okay, so I need to see this. This I'll tell whenever I find time. I'll tell. Okay, I can't waste time on this. Okay, I'll make it sure. Next, with this I'll explain and leave. I'll take 2 minutes. So what is asked? See, it is given. There is no divided by here. See here, it is given x naught is given. They are given x of t. It means when x naught or your initial condition is 1 and -1, your answer was your your input or your x of t was e power minus t and this. Now when the initial condition becomes 0 and 1, it changed to x of t this. Now they are asking, if your initial condition is 3 by 5, what will be your x of t? So they have solved using the linearity functionality. That is k1 of t is equal to, I'll go directly because it's almost time up, right? So k1 into x1 of t is equal to Laplace inverse si minus a inverse into x1 of 0 into k1. See, I'm multiplying with k1. As you know, x of t functional, right? X dot of t, what it was? Into x of t, right? So when I take Laplace, what will happen? X of s will become as si minus a inverse into x of 0, all right? Into your x of 0. Then I take this. Okay, so you'll be getting value of k1 and k2. You will solve and you will get k1 and k2 value. Now similarly put for the kt. So x of t will be equal to k1 into x1 of t and k2 into x of t. What is your k1? 3 and 8. And put the values. Means I'm equating, see, these two. See what I'm doing, I'm taking this initial value and this initial value. Okay, here in this. Okay, I'm taking this initial value 1 and -1, 0 and 1. So I'm measuring 3 by 5. How I got? Means what proportionality I multiplied with this. Whether I multiplied with 2, 3, 5. Okay, with what proportionality I multiplied this, and with what proportionality I multiplied with this, so that I got these two answers, right? The next thing is your 3 by 5. So I'll equate these two 3 by 5 with the multiplication functionality. That is, the k1 into the first one, k2 into 0, 1 is equal to 3 by 5. So 3 by 5 is this. I'm multiplying with these two, right? I got this. Then what I'll do, I'll multiply this k1 into x1 of t and k2 into x2 of t, and I'll be getting an answer as this. So this is still 2 marks question. I need to go in depth and see. I will be having only 2 hours. So in 2 hours, how much I can do, I have done, right? So I hope control system was. I think you can able to solve at least 1 mark questions now from your block diagram till the state space analysis, right? So if you have any doubts, you can text me. Okay. And how was the session? Means the control system session.
Good, sir.
I don't want this answer. Okay. Something should be there. Okay. Helpful, good, excellent. Okay. Those are common words, now. Okay, fine. So no issue. If you have any problem, you can text me with respect to control system. I'll try it. I'll solve it and I'll mail you or I'll WhatsApp you. If you face any difficulty in solving any problem in control system, just text me and I'll be helping you. Okay.
Sir, can you send these materials, the PPTs?
PPT. Okay. Other than that, what I planned, I'll be giving you some materials. Okay. Like Gate Institutes, they're famous. Like you might have heard of ACE Institute for Gate and Made Easy, Wani Institute, correct? So there are many institutes. So these institutes I'll be giving you the materials.
Sir, yes.
Made Easy. So ACE will be much stronger than the Made Easy, right? But I can't put in this website because I need to again overliming my copyright, right? So now I'll be see this Made Easy. You can purchase the material. What I told, no, handbook by Made Easy for electronics and communication. That will be helpful in your engineering. To write engineering based any exam, whether ISRO or DRDO, any exam, this handbook will be very helpful for you. Okay. And ACE materials I'll forward you. I'll put in the Google Classroom. I'll create a Google Classroom. I'll give you the access so that you can access. And parallelly, I'll tell to other sir also to put digital electronics materials.
Yes, sir.
Okay. So I hope you learned something new with respect to your control system. I hope at least you can solve 1 more questions now. Okay, so any doubts you can text me personally if you want. Okay. So any more queries? Any more doubts? Anything?
No, sir.
No. Okay, then we'll meet. Because the next will be okay from next week onwards. I think Manoj sir will be starting your analog electronic circuits, AEC. Analog electronic. Fine. Okay, then see you in the next class.
Thank you, sir.
Okay, bye.
Thank you, sir.